Hello everyone, this is lecture 5 of week 9. We have been learning about the simplex method, and in the last lecture we gave the full algorithm of the method, right. So, one thing you might have noticed in the algorithm is that it is very different from the algorithms that we have seen until now, right. So, all the algorithms for unconstrained optimization had a particular format. I mean it was just to find the descent direction and the step size and the stopping criterion, right. Even in the algorithms for nonlinear programming, the quadratic penalty method and augmented Lagrangian function, right. Yeah, the method was almost the same. I mean, we just had an inner loop and an outer loop, but we were still doing the same. I mean, searching for descent directions, searching for the step size, and so on, right. This algorithm is very different from what we have learned until now, right. So, keep that in mind. This also has a stopping criterion, which is the Cn transpose minus Cb transpose B inverse n being greater than or equal to 0 for all the elements, right. But the search is not for the descent direction and the step size, but it is for the nearest vertex. Okay. So, it is the right exchange of basic and non-basic variables that is actually the search in this particular algorithm. Okay. Fine. So, we will look at an example, and we will also complete the code for simplex method in this lecture. Okay. So, consider the same example that we were working until now, right. So, yeah, it is this where you minimize C transpose x. Okay. So, now I will write this as minus x2. Okay. Subject to the constraint that, to just put it bluntly, it is minus x1 plus x2 greater than or equal to 0, x1 plus x2 minus 1 less than or equal to 0, sorry, this is minus x1 plus x2 less than or equal to 0, x1 plus x2 minus 1 less than or equal to 0, and minus x2 less than or equal to 0, right. So, if you recall, the first step actually is to convert the LP into standard form, that we have already done, right. So, yeah, that is the, so the problem now becomes like this, it is min minus x2, of course, this is not going to change, subject to this constraint minus 1 1 1 minus 1 1 1 1 0 0 1, and this is x1 plus x1 minus x2 x3 x4 equal to 0 1, and yeah, so all of them must be non-negative, x1 plus x1 minus x2 x3 x4, all of them need to be non-negative. Okay. So, the first step is done. Okay. So, the first step is done. The second step, if you have a look, yeah, so you need to choose m independent columns of A. So, I think we did a great job of that. I mean, we saw all 9 possible independent vertices, right, and I mean, saw that they actually give only 3 vertices, right. So, I mean, I am going to now choose x3 comma x4. Okay. Just for the sake of, I know that the answer is half comma half. So, I want to choose a vertex which is not the answer, right, otherwise I would have I would stop in the first step, right. So, I am going to choose x3 comma x4 as basic, and x1 plus x1 minus and x2 as non basic. Okay. So, yeah, if I do that in this matrix where you have minus 1 1 1 minus 1 1 1 1 0 and 0 1, right. So, this becomes, these two become the basic variables, and these two become, sorry, these 3 become the non basic. Okay. So, yeah, A is this. So, we have B is 1 0 0 1, and n is minus 1 1 1 1 minus 1 1. Okay, fine. Now, what is CB and CN, right? So, C if you look at is actually 0 x 1 plus 0 x 1 minus minus x 2, sorry, so I will write as plus minus 1 of x 2 plus 0 x 3 plus 0 x 4, right. So, since x 3 and x 4 are the basic variables, right. So, again I will write that x b is x 3 x 4 and x n is x 1 plus x 1 minus and x 2. Okay. So, you have C b is 0 comma 0, that the ones corresponding to x 3 and x 4, the coefficients corresponding to the basic variables is C b, and the coefficients corresponding to the x n is actually C n. So, it is 0 0 and minus 1. Okay. So, that is going to be our C n. Okay. So, I have figured out B, N, CB, Cn, and B is already there. B is just 0 and 1, what is there here. Okay. Yeah. So, this is B, right, Ax equal to B, that is it. So, B does not change, B is just 0 comma 1. Okay. In C I have figured out CB and Cn, in X I have figured out XB and Xn. Okay. So, and what is the basic feasible solution? It is xb comma xn, which is B inverse into B, B is just I. So, I inverse is I inverse B is just B. So, it is 0 1. So, xb is 0 comma 1 and xn anyway is 0 0 0. Okay. I mean the order is changed. So, note that this is actually x 3 x 4 x 1 plus x 1 minus and x 2. Okay. But nevertheless, yeah, this is so we have actually found. So, in this we have chosen m independent columns, the variables corresponding to independent columns are basic, the others are non basic, the solution and B inverse B is greater than or equal to 0, and we have just converged at the basic feasible solution. Okay. Fine. Let us go to the next step. So, I want to check now whether this particular vertex, whatever we have got 0 0 0 0 1, right, whatever that is that satisfying the Cn transpose minus Cb transpose B inverse n, is it always non negative, right. So, Cn transpose minus Cb transpose B inverse n, right. So, note that Cn transpose is 0 0 1, yeah, this is actually transpose, I should say that, this is C transpose x. Okay, yeah, that is fine. So, yeah, this is 0 0 minus 1 minus, so this is 0, so whatever is here does not matter, right. So, yeah, and B inverse is I, so n is this, so 0 0 into this is actually 0 0 0 0 0 in fact. Okay. So, or I will write it if you want 0 0 into I inverse is I, so I will just leave it, n is this minus 1 1 1 minus 1 1 1. So, that is 0 0 minus 1, this is 0 0 0, which is 0 0 minus 1. Okay. So, this is certainly not all positive, right. So, you have one negative variable, right. So, yeah, the loop is not complete as yet. So, there is some I for which it is less than 0. Now, what is Q? It is the minimum element of Cn transpose minus Cb transpose B inverse n, right. So, yeah, the minimum element is minus 1 and that corresponds to x 2, right, because xn is x 1 plus x 1 minus and x 2. So, this is corresponding to x 2, right. So, therefore, Q which is argmin over I of Cn transpose minus Cb transpose B inverse n of I is actually 2 actually 0 1 2. So, it is x 2, right, or actually 1 plus 1 minus and 2, right. So, it is 2. So, therefore, x 2 becomes basic in the next cycle, okay, in the next iteration. So, x3 and x4 were the basic variables in this iteration. In the next iteration, x2 is going to become the basic variable. Fine. Now, let us the next one is to figure out I. What is I? It is set of all I such that B inverse n of I comma q is greater than 0, right. So, let us figure out what is B inverse n in the first place. B inverse n is just B is I. So, it is just n, it is minus 1 1, 1 minus 1 1 1, and it is corresponding to the last column, right. So, B inverse n of q is 1 comma 1, okay. I am just taking the column corresponding to q, right. So, that is 1 comma 1, and we so which are all values are positive, of course every value is positive, right. So, we have I is both 3 and 4, okay, both the variables, which is yeah, the first variable of xb and second variable of xb, which is 3 comma 4, okay, all right. So, now what is j? J is argmin of I of B inverse B of I by B inverse n of I comma q, right. So, B inverse B, so B is I, so identity, that is. So, B inverse B is 0 comma 1, right. So, yeah, for one of the variables it is going to be 0 by 1. So, we are just finding the argmin of 0 by 1, and the other one is 1 by 1, okay. So, of course, it is going to be 0, that is the first variable. The first variable is 3, right. So, j is equal to 3. What this means is that x3 is going to become non basic, okay. So, in iteration, the next iteration, okay, we will have yeah, the set of basic variables will be x2 and x4, and non basic variables will be x1 plus, x1 minus, and x3, okay. So, the loop should continue, okay. I mean you can see what all happens in, I mean each of the iteration, right. So, let us actually continue this using a Python code, okay. I mean we will use this example initially and then go to the other examples later, okay. But this is to give you an idea of a particular iteration, okay. Fine, let us go ahead to code, okay. Simplex algorithm. We can start by importing numpy, and yeah, so we have to define the sets B and N, right. So, yeah, B is just an identity matrix here, right. N is yeah, so if you recall it is minus 1, 1 and 1, that is a 2-dimensional array, and it is 1 minus 1 and 0, okay. Yeah, so I have just repeated what is written here, n, okay, minus 1 1 1, 1 minus 1 1, yeah, so minus 1 double 1 and 1 minus 1 1, okay. So, that is n, okay, and CB was zeros, Cn was 0 0 minus 1, and B is 0 and 1, right, and yeah, we will also initialize k, I mean which I will call it as iter here. Okay. So, this is the 0th iteration. Okay. And since we have to print x in every iteration. Okay. So, I will first initialize x as all zeros, and how many zeros are there? It is the number of elements in CB plus number of elements in Cn. So, I will write it this way. Yeah, so that is the number of elements in CB, and then you have the number of elements in Cn. Okay. So, fine, yeah, that is x, and oh, okay, yes, this is something that I missed. Yeah, so you should also initialize what is B set and N set. So, yeah, I mean instead of writing 1 plus and 1 minus, let me actually write that as 0, 1, 2, 3, 4. Okay. So, B set is 3, 4 and N set is 0, 1, 2. Okay. So, I mean if you see what I have written in all these places, it is just a repetition of what we have here. I have written B, yeah, the B that I have written here, N, XB and XN is the B set and N set, it is 3, 4. Instead of 1 plus and 1 minus, I write 0, 1, 2, okay, 0, 1, 2 and this is 3, 4. Okay. I have written CB, Cn and little b. Okay. Now, this XB and XN should be found by B inverse B and 0. So, that is what I am going to do now. Okay. So, X is all zeros, okay, of which in B set it has to be B inverse B, right. So, it is NP dot linal dot in of B at little b, sorry. Okay. Okay. So, yeah, the others are anyway 0. So, I will print the iteration. So, which iteration we are in? Yeah, that is of course 0, but nevertheless, and the next one is x. Okay. Yeah. So, this print is just to track where we started at. Okay. Now, we will write down the loop. Okay. So, note that, so we are actually doing this Cn minus Cb dot B inverse n, right. Okay. So, yeah, but what we want is that we actually want to check whether the while loop should go on until one of them is less than 0. Okay. So, what I am going to do is, so I am going to check if yeah, this is less than 0. So, this would actually give a set of Boolean values, ones and zeros. Okay. So, yeah, if everything was greater than or equal to 0, then all of them will be false and the sum will be 0. If the sum is non-zero, then it will go into the loop. Okay. So, that is what I am going to do here. I am just going to write NP dot sum of this quantity not equal to 0. Okay. So, just to have a look of what is happening, this quantity Cn minus Cb into B inverse n. Okay. So, I am checking for what all value what all elements in this vector is negative, right. So, if every vector is greater than or equal to 0, then the sum is 0. If it is not, then it is not equal to 0. So, when it is not equal to 0, you will go inside the loop. Okay. Fine. So, recall that the first step is to find the argmin of this same quantity whatever we had written here, right. Cn minus Cb transpose Cn transpose minus Cb transpose B inverse n, right. So, yeah, I will just do that. Okay. Yeah. Now, yeah, finding J is a little bit tricky because I need to find B inverse B by B inverse n for all I such that B inverse n of I comma q greater than 0. Okay. So, I will do so by the following code. Okay. So, I will initialize min and j as follows. Min I will initialize as infinity and j I will initialize as -1. Okay. So, for I in, so I have to do this for all values of I, right. So, yeah, this is shape of CB of 0. Okay. If B inverse n, okay. So, okay, yeah, not all of this, yeah, B inverse n of I comma q is greater than 0, yeah, that is when you go into the loop. Okay. So, yeah, j will be I if yeah, so if what you have turns out to be the minimum, so that will be this np dot linalg dot inv of b at b of I by, yeah, b inverse n of I comma q, yeah, so I will remove this. Yeah, so this is actually less than min. Okay, so you have some minimum. If what you have here is less than min, then yeah, you have to modify the value of I. Okay, and similarly, min equals this quantity if, oh, okay, so I should have removed the min. Yeah. Okay. And yeah, so the other one that I have to do is to verify for unboundedness. So, I will first initialize z to be false and put z equal to true here. Okay. And yeah, so if z were false, then you should print unbounded and move out of the code, right. So, yeah, yeah, I am not sure if you have understood whatever I have written. Okay. So, yeah, in all of these lines, okay, what I have done is what is given in the second and third bullets. Okay. That is to find which j minimizes B inverse B by B inverse n, okay, among I in capital I. Okay. So, that is exactly what I have done. I will explain what is going on. So, I have initialized min to be infinity and j to be yeah, some nonsense value because I am never going to get -1. Okay. And so, and I am checking for all possible values of I. If B inverse n of I comma q is greater than 0, only then I am going inside the loop, otherwise I am not going inside the loop. Okay. So, note that if I never go inside the loop, that means B inverse n of I comma q is less than or equal to 0 for all I, right. So, then z will remain as false and that means it is unbounded. Okay. So, z is like a flag. Okay. So, yeah, if it even if it goes inside once, then z is true and thus it is not unbounded. Okay. Fine. So, but what am I doing here? What I am doing here is that if yeah, I am storing the minimum in the variable min. Okay. If yeah, b inverse b of I by b inverse n of I comma q is less than the minimum, then yeah, j becomes I and min becomes b inverse b of I comma b inverse n of I comma q. Okay. So, this is a way by which I am computing both the minimum as well as the min as well as the arg min. Okay. So, that is basically what I am doing here. So, in all of these steps what I have accomplished is to find the value of j. Okay. So, I have found the value of q, I have found the value of j. now I have to make xq basic and xj non basic. So, let me continue with that. So, you have b set of j and n set of q becoming n set of q comma b set of j. Okay. So, yeah, that is a nice way of exchanging that Python has offered, right. So, when you write a comma b equal to 0 comma 1, you know that it is a is equal to 0 and b is equal to 1, right. So, that is exactly what I am doing here. So, b set of j will take n set of q and n set of q will take b set of j. Okay. So, yeah, that is to change b set and n set here. Okay. That is not sufficient, I also have to change b and n, right. So, I will do the same thing, b the jth column of b and the qth column of n is equal to the qth column of n and the jth column of b. Okay. Again I have interchanged the columns in b, the other columns remain the same, please note that. Okay. All right. So, again that is not sufficient, I have to change Cn, right. So, Cn will be Cn of q, or I will write it as Cb because that is how I have been consistently writing. So, Cb of j Cn of q equals Cn of q and Cb of j. Okay. Fine. So, that is another exchange that I had to write. Okay. So, other than this I also would like to change certain other values. Okay. So, exchanged Cb and Cn, right. So, yeah, these are the exchanges that we had, and we will also do an increment of the iteration, right. So, we will write it as iter equal to iter plus 1. Okay. So, we now have to print the value of x. So, since we have done all of this, right. So, we will do this x, I mean we have to do this again, x will have all zeros, right. Okay. The b set will be capital B inverse b, and so for each iteration we are printing x. Okay. So, let us check if this works. Okay. Okay. So, since I have instead of if else, right. So, since we are writing it in one line, we write this. Okay. So, what this means is that, so j is equal to I if this holds, j equal to j itself if this does not hold. Okay. So, I have to change this here as well, min is equal to this if the condition holds, if the condition does not hold, then stop with min. Okay. So, that is what it means. Okay. Okay. So, let us see if it is correct at this point, there should be a comma here. Okay. So, that is the answer. Okay. So, we have got half 0 half 0 comma 0, right. So, if you recall, this was x1 plus, x1 minus is 0. So, x1 is actually half minus 0, that is half, x2 is half, and x3 and x4 does not matter. So, half comma half is the answer, and we have actually got that. So, I mean it may not be very clear because I have not printed the b set and n set in the for each of the iterations, right. So, maybe let me do that as well. So, let this be b set equals b set and n set equals n set. Okay. So, that we understand what happened a little better. Okay. Yes. So, we initially started with 3 comma 4, you can recall, and n set was 0 1 2, and even when we worked out by hand, you can see that you saw that 3 was replaced by 2, right, and yeah, 3 went here. So, you can see that B set is 2 comma 4 and N set is 0 1 3, but even there the corner point did not change, that is again 0 comma 0, but in the next cycle 4 was thrown out of B set and 0 was taken in. So, 0 comma 2 became the B set and 1 3 and 4 became the N set. So, 0 and 2 are non-zero, as you can see, x 0 and x 2, but x 1, x 3 and x 4 are zeros, right. So, that is the answer. Okay. So, yeah, this is the coding of yeah, the simplex algorithm. So, if you want to code for other linear programming problems, please note that you only have to change part, right, B n, C B, C n, B, capital B set and capital N set. So, if you change that and keep the other part the same, yeah, of course, you will still get the answer. Okay. So, yeah, I actually want to work out more problems because yeah, since this algorithm is really complicated, right, or in fact it is very different from the earlier algorithms. So, we will continue this into week 10 as well before we start with the next algorithm. So, yeah, we will stop with the lectures of week 9 now, and we will continue with some more examples before we go to the next method in the next week. Thank you.